Hello, my name is Loran Hendricks, and today I'm going to be talking to you about the life and death of a star. With an explosive last breath, a star dies, although in its death gives life to countless more stars. The life cycle of a star traverses through two main phases: birth and then finally death. A star ends the same way it begins, in the form of an interstellar cloud. An interstellar cloud is also known as a nebula. The cloud contains thousands of times the mass of the Sun. Most astronomers think that some cosmic event triggers the cloud to start collapsing. Stage 2, the cloud collapses and begins to fragment. The temperatures in the cloud remain the same throughout stage 1 and stage 2. The cloud stops fragmenting, and eventually the fragments start becoming very dense. Stage 3, the fragmentation ceases. The contracting cloud is beginning to resemble a star. The dense opaque thing in the middle is called a protostar. As a protostar evolves, it shrinks. Density grows, temperatures rise. Hundreds of times larger than the Sun at this point. A protostar is still not yet in a state of equilibrium. During stage 5, the protostar goes through a thing we call protostellar evolution. By stage 5, the protostar has shrunken to about 10 times the size of the Sun. Events begin to happen more slowly now as the star begins to reach main sequence. And then stage 6, a newborn star arrives. Temperatures are now around 10 million degrees Kelvin, enough to ignite nuclear fusion. In the core, protons begin fusing into helium. Finally, the star is born at stage 7, and you have the star on main sequence, which is what our Sun is at currently. Temperatures climb to 15 million degrees Kelvin, and they remain the same for the next 10 billion years. Stage 8 begins the death cycle of a star. As nuclear fission continues, the interior of the star begins to change into materials that are more dense. Helium increases and hydrogen decreases. At the 10 billion year mark, hydrogen reserves are completely depleted. The star begins to become unstable, unable to make nuclear fusion because the temperatures are not high enough. Stage 9, our star traverses the red giant branch. The core is unbalanced, full of helium and shrinking upon itself. The red giant is massive, about the size of Mercury's orbit around our Sun. 25% of the star's mass is packed into the planet-sized core. During stage 11, helium fusion continues. The smaller stars will continue to collapse and then eventually fall apart and spread throughout space. For some, this is their death, but for others, life will go on. After a few 100 million years away from the main sequence, temperatures rise in the core and helium begins to burn. The helium atoms begin to fuse into carbon, and then on stage 11, we come back to the giant branch. The helium is rapidly depleted, leaving nothing but carbon. The core begins to shrink. The star itself increases in overall size. Then, stage 12, we have a planetary nebula. By the time this stage is entered, the star is about 300 times the mass and size of our Sun, which is also big enough to engulf Mars. The core is a small and well-defined core of carbon ash. The outer layers fuse carbon and oxygen still. During stages 13 and 14, the star goes and leaves a white and black dwarfs. The carbon core at the center of the planetary nebula continues to evolve. As the envelope of the red giant star recedes, the core becomes visible. Left, as I said, is a white dwarf. The stars will then either go nova or supernova. If they go nova, they increase their luminosity by 10,000, then they return back to their initial luminosity. This can last anywhere from a week to months. Fusion continues, creating heavier elements, and the ones that didn't go nova The heavier elements cause the star to continue collapsing on itself. Eventually the star collapses so much that it explodes into a supernova. Sometimes we can see the explosions on Earth. In many other ways we can detect the remnants of the supernova in the forms of nebula. A star begins a multi-billion-year lifespan in the form of an interstellar cloud. During the life of a star, it traverses through two main phases, which consist of about 14 different phases or stages. Eventually, a star will reach the end in a few ways. They either become white or black dwarfs, go nova, or in the extreme cases, go supernova. When they go supernova, new life is born from the remains. Are there any questions? Yes.
Is there only one star born for each interstellar cloud?
There is no evidence that a single star will be born from an interstellar cloud. Next question, please.
What is the approximate life expectancy of a star?
A star's life will traverse through roughly 11 billion years. Next question, please.
And finally, what is the difference between nova and supernova?
A nova explodes into luminosity with no actual particles expanded. A supernova, the star dies completely and new life is then born. And that will be all, and thank you for your time.